the bright side, I can still see the chat if I move here, and I can see what's going on. This is probably a very strange view for you, but anyway, I also have tea, so okay, let's go ahead and just jump right in. So in our previous one, we set up this, and we have a server function and a client function, and these are basically going to be running in separate threads. Those threads are going to allow both operations to be performed at the same time. And I don't remember, did we make our server multi-threaded itself? I don't think we did. Nope, it does not look like it. So that's fine, we can do that at a later date. But really what I want to do first is talk about how we are going to do this. So there are a lot of ways we can share this list. It could be you ask me for the list, I give it to you, or it could be that I just give you the list randomly. So I, as a node, am just sending my list out to everybody in my list once in a while, and everybody just has a specific address by which they are going to do that. Or it could be a client function that runs once in a while that goes out and just asks a random node for a list. And there are sort of pros and cons to each one. For one thing, we sort of have to commandeer the client function for a moment if we are going to have that go out and ask for a list. That being said, if I only send it to someone when I ask them, or only being sent when it's asked for, then that's going to take up a lot less network traffic. So if you imagine, if I have a list of 100 addresses and you have a list of 100 addresses, and each of those have a list of 100 addresses, and let's say some of those overlap and some of them don't, then the list just gets exponentially larger every time we send it. So that would be kind of a problem. So maybe we will actually do this as a client function running on some sort of timer, and when that timer goes off, that thread will just use the client function to pick someone on our list to ask for their list, and then they will respond using the server function with that list. But we are going to want to do this in a certain way, and it's going to relate back to the way I was originally doing my HTTP server. So if we come into network and HTTP server, we could see I had this register routes function, and this was to make something like a Flask interface or web framework for an HTTP server. And if you've ever used Flask, the way it works is that you take the routes on your website, the different URLs that you would use. So ericomeehan.com/home or /users or whatever it was. And you would just basically define what happens as a function. And I really liked that way of interfacing with it. So I want to change our server object here to itself have a routes function. And we can do a lot of copying here because the HTTP server will actually show us a lot of what we need. So let's open them up side by side. So in our server, now, before we actually do this, let me explain some of the reasoning here and take a quick sip of tea. So I'm basically deciding that this is what we're going to do because I feel it's reasonable to assume that anybody who wants a server object is going to be serving something seems reasonable, and they're going to want to specify a route by which you can access that. So you could say, in the most generic case, you could have a server object that always returns one thing. You could say that. But you are almost certainly going to have a server that is going to be giving out multiple things, more than one thing. And you're going to want to separate those with these routes. So I'm going to decide, I've decided to add this route function to my server constructor. And I feel that if you are creating a server that doesn't need routes, then you can really take the cost of carrying this function along in the struct anyway. And so I think that the memory cost of sticking this in there is absolutely worth it. So we're going to do it. Let's just go ahead and do it. So let's add it in here. Well, we want to do this in server.h first. We're going to have a function. Calling it register routes. And it's going to take a reference to the server itself. It's going to take a character pointer. What is that? That is itself. That is the function. I say character pointer returning function, route function, and that takes a struct server, a reference to the server itself, and okay, there we pass in the HTTP server right here. We pass in a request object, an HTTP request object. But we don't do that here. We're not actually using those. And we're getting this HTTP request object in the library, at least, through a constructor. And that constructor is taking a character pointer. So if we look at the constructor, we pass in the request string there. So instead of doing that, we could copy what we pass into the request constructor and just pass in the string that we receive. So where is our, there we go. Okay, so instead of passing in a HTTP request object, I'm going to pass in, because it was wobbling a bit and I don't want it to fall on all of my stuff. Anyway, so instead of that, we are going to pass in a character pointer, and we are just going to call it request string. Okay. And last, we are going to pass in a character pointer. We'll call it path. Now, in the HTTP version, we passed in the number of methods, and that referred to the REST API protocol, basically, where we have get, set, put, delete, all of these different protocols. And you would essentially choose which protocols you were allowed to use on a route. But as far as I can see, you can make a route do absolutely anything you want. So, I mean, I don't care what protocol someone uses. So why would someone use a delete protocol? Why does it matter that they actually specify that? So here in the HTTP version, I actually had them specify the number of methods that they would use, and then I had an enumeration for all of those different methods, and then they could put an arbitrary number of them up to the limit of which ones they were using for that route. But here in our peer-to-peer network, we can use any protocol we want. So I'm not so concerned with having them specify different kinds of methods because we can do whatever we want. So it doesn't matter. We're just not going to specify anything like this. So I'm just not going to add that into the register routes function over here. So we'll put that in. That should be good. And now we actually need to define it. So let's come over here and put HTTP server, and this is server.c. So let's see. We're going to want a prototype. We'll just copy it here. And I'll add in some comments later Oh, but you see, I'm not going to be able to use that. See, this is the problem I keep running into, is that I compile all of this together into one big library, into a .a file, and it's a static library, precompiled library. Anyway, it compiles all of this together, all of these files together, and if anything has the same name, then it doesn't work. So I need to give everything a unique name in the library. So we're just going to add register routes server, and that will change the name. But we don't need to change it in the actual server.h. So here we can still call it register routes because it's contained in this server object. So its scope is not global. Whereas here, once this gets compiled all together, its scope is mixed with all of the other .c files. So between them, everything has to be unique. But these have a different scope, so we can name them whatever we want. They're also just actually pointers. They're just memory addresses of where these functions are. So anyway, we will name the actual definition something unique over here, but we need to change some of these. So get out the num methods. You know what? Why don't I copy the one that we're actually And so as to be a good host, let's take a brief check on the chat. And I don't see anything there. I'm sure that's a very strange perspective for you guys, so I don't want to go over there too long. And I will continue checking Sidecar. Hopefully, at some point, I will get my iPad connected. I don't think now's the time. Okay. We continue right along. So we're going to register our routes, and we're going to need to change that to server. And let's define thing there. Find it down here. Again, I'll add comments later. Oh, by the way, I have a link in the description. I believe there's a link in the description to my GitHub. And I can, at any point, just add everything. And what do we just do? What are we going to do? Started adding routes. So you can just go to the... I'm surprised I got that right. Anyway, yeah, you can just go to the GitHub. There should be a link in the description. And you can keep up with and look at exactly the same project that I am looking at here. So if you're interested in seeing the code, feel free to go and look at it on GitHub. Anyway, we have our register routes to server. And what do we do in the HTTP server? Okay, here it is. So we here have a struct. We call it route. And this is actually pulling out the number of methods and adding it to the route. We have a character array buffer for the URI, and we set that in the route, and then string copy it over. We copy over the route function, and then we have a dictionary in server called server routes, and we insert into it all of these things. So we can largely copy that, but we need to look at our server.h first. So we're going to need a dictionary. So struct dictionary, we're going to call it routes. And then on our constructor, what went wrong there? Oh, I need to include our dictionary. Data structures, lists, no, it's dictionary / dictionary.h. Okay. There we go. Okay, so we need to actually initialize. So, before we actually connect the sockets, let's initialize the dictionary. So, dictionary constructor, it takes a compare function. And I believe I have one somewhere. Do I have a string compare string keys? That should work. So the dictionary is in my library based on a binary search tree. And what it does is basically it contains all of its inputs as a entry. So this object over here. So it will contain everything as a key value pair. And then the comparison function that you pass into the dictionary constructor will actually use the entry struct, but it will pull out the key and do a comparison based on the key. So you need to pass in a comparison function when you actually initialize this dictionary. So I provide one in the dictionary.c file somewhere, compare string keys. So this is the function I'm actually going to use. So the way this is actually working is that in the route function, where is that? I'm getting too many tabs here. I don't like it when there's rid of this window. So in our server, here we are creating a dictionary to store our routes, and we pass it that comparison function. Now, we want this dictionary in here because over here we have a register routes function. And the register routes function is going to take a certain URI, a path that the user will specify, and have a value associated with it that is the pointer to the function that it is going to use. So when a client connects, and let's say I have registered the route /users. If a client connects on /users, then I will be able to see that that's what they're asking for, and I can execute a function. And that function will do whatever I want since they've accessed that route. And that function is defined as the value for that dictionary. So we need the dictionary. And we need to initialize it in the constructor. And we are going to need to create our register route itself. So, okay, we actually do still need that side window, but let's close a bunch of windows over here first. Chat. Nope. Okay. Okay. So, let's largely copy what we have in our HTTP server. Register right there. I might have an odd angle on the microphone here. Worried about moving it. Hasn't fallen yet. This might be a bit better for when I'm actually typing. Otherwise, like right in my line of sight. Okay. So here we defined a struct route. And what is that? That's a little too low because now I'm hitting it with my... Might get loud for a second, so I apologize for that. Very professional, but not much better, but okay. So what is a route? So that is actually defined here. Where is route defined? Route, there it is. Okay. We have an array of methods, but that's unnecessary. And then we have the URI and the route function. Now, the question is HTTP server, where we have a set number of methods that we can use, and we want to say 1 or 0 whether or not those are being used. We have a character pointer that is going to be the URI, but that's also the key by which this is being stored. So we kind of already have that somewhere. And then we have another, or a route function that is turning a character pointer itself, and it takes the server and the request as its input. So if we are storing these as a key value pair, we're already sort of storing both of these in the dictionary. So I don't think we need the route. So let's actually jump into our money where our mouth is and see if we don't need that. Okay, so we're going to register a route. So I guess we could just say server routes dot insert, and the insert function takes the address of server routes. Then we need the I need to look this one. There's a number of things in it. Insert takes the dictionary itself, a void pointer to the key, and the size of the key bytes. Then we take a void pointer to the value and the size of that value. Okay, so our key for this is going to be we got the request string. How does it get the URI? Wait a moment. Path. I call it path over here. But why am I getting a request string? Oh, okay. I see. The request string is coming as, you see, that is sort of the problem with using these function pointers as much as I am using these function pointers, is that it becomes a bit confusing looking at all of these parameters, because it looks like my register routes server function takes request string as an argument. And what was confusing me right there was why. Why would it take that as an argument? And it is, in fact, not taking it as an argument. It takes this route function as an argument. And this route function itself takes request string as an argument. So this is basically telling us the format of what this argument is going to end up being. Which is interesting, but it does not itself take those. So we have the path. Anyway, so our key is going to be path, and we will have the size of, and I am still not quite sure what I should be putting into this part. I'm going to look at the chat. Here we go. Brooks Burris. What is your goal for the peer-to-peer network? Hobby project, or do you have some application in mind you want to apply it to? Oh, Brooks, that is a fantastic question. I do have a plan, actually, of what I want to do with this. So that's going to lead me into a question as well, a question for you guys. So the plan is that I just want to get a peer-to-peer chat network going first. And then I want to start playing with some cryptography things. So I don't think I'm going to be putting. I'm not going to be mimicking what they do with in HTTP with HTTPS, where they have this like handshake that goes on between the client and the server. They pass back and forth a public and private key. I'm not thinking that. I have a different idea, sort of like a blockchain, where you could essentially do a hashing function for whatever you're sending into the chat network, and it creates a blockchain sort of thing out of it. And so that is essentially the plan for what I'm making here. And the question I have is, what should we do about third-party libraries? So I started this channel kind of promising myself that I would not be using third-party libraries. And I'm not totally anti-third-party library. Of course, they're often useful. It's just they always leave a question me about, well, how does it work? So let's take SHA-256, for instance. The next step in this series could be programming SHA-256 from scratch. I am absolutely happy to do that. I have wanted to do that for a long time. So we could go down that route where I am going to program SHA-256 from scratch. And we would actually probably want to use SHA-512 in order to be more modern with what we are using. But anyway, I can program that from scratch, and we could do that. But we could also skip that step. If we want to get to the end product quicker, we could use OpenSSL. They have a C library, and I'm sure SHA-512 is in there, and it would be as simple as learning how they do it. So the question is, what do you want to see? Do you want us to program SHA-256 from scratch, or should we use a third-party library? I'm going to create a poll. I will put that poll in my community thing on YouTube, and see if I can do that right now, even if I dare. Honestly, I am not quite sure how. Discussion. Can I do a poll? I don't think I can. So I'm going to, I'll put something up there later. Feel free to put it in the actual chat here. I'd love to hear your comments, but there will be a poll at some point about that question. So let me know what you think. Anyway, let's hop back in. So I still don't have a great answer for what size of should take. I have been putting in the size of a character array that has the number of elements that is equal to the string length of not URI, but path. And we need the string library for this. That's what I've been putting in there. It works. Usually. So I don't think I've run into a circumstance where it hasn't worked actually, but I'm not quite sure what should actually go in there because that seems a bit ridiculous. Anyway, so we have that. I should just write my own size of function that handles this for me, so I can just pass in just like some argument and it will just return this. Anyway. Okay, so now we need the value, and the value here is going to be route function. And I think I see why. I see why I was wrapping this in a struct earlier. It's a bit strange. Am I going to pass the size of a route pointer? Let's see. Size of route function. Will that insert it into the dictionary for me? Looks like it. No problem so far. Have a sip of tea. Okay. So that's pretty. Is that all we have to do? Route function. Register route. So over here, we had to create a route struct. We don't have to do that. We then had to enumerate all of the different methods using this ellipses argument, which we don't have to do at all anymore. We then had to use string copy to copy the URI into the route, which, I mean, now we're just using it as the key directly. So we can just do it, that whole thing in one function. Okay. So why would we have a function for this? Why don't we just say well, if you look over here, and what I'm thinking is over here in our .h file, we call it register routes. Why don't we just have register routes point to this? Well, you see, we could do that basically exactly the same, but what would the user have to pass in? They would have to pass in their route function. We just say register routes equals server routes.insert. Yeah. Okay. So we're going to register those. Say register routes equals routes, well, server dot routes dot insert. See, okay, so there is a reason to do it as a separate function. It's a little bit messy. Let me see if you guys have anything to say about it. Okay, so here's the deal. It's a little bit messy both ways, and we kind of just have to make a decision here. So if we use this insert function as it is here in the constructor, so if we just basically do a little swap so that the routes dictionary, we just take that dictionary's insert function and we pass it in as the server's register routes function, that will work. But when we actually go to register a route, we are going to need to pass in as the first argument, rather than the server, we're going to need to pass in the server.routes dictionary. And so if we do it like this, we need to pass in a reference to the dictionary rather than the server when we're actually using it. If we use this additional function, we can basically change the name, because we can have the user pass in the server rather than the server's routes dictionary, and then just call the server's routes dictionary and pass in those two things that they want. Also, the user won't have to pass in the size of any of these things. They can just pass in the themselves. So more and more, it looks like this is just a cleaner user experience. So this function is largely just renaming this function. but it does it in such a way that makes it a more convenient use. So I can, as the user, I can just say, well, I'm working on this server, and here's the function I want to run, and I want to run it when they access this path. And what you're going to run is this thing to insert it into the dictionary. But the user doesn't have to think about a dictionary. They don't need to think about inserting things into anything. They can just think about their routes and their paths. That's it. So I'm going to actually rename the function here. So instead of doing that, I'm going to do this. Kind of like just an interface for that dictionary that lies. The dictionary already has an interface, but it's an interface to the interface that makes it even easier for me to work with the dictionary in my particular context. Anyway, server.registerRoutes is going to equal register routes. That's kind of funny. Register routes server. I shouldn't have done that. Server.registerRoutes equals register routes server. That's naming things in programming. Okay, so I suppose the next question. Move again. Good. It seems nice and sturdy, so I'm worried that it's going to fall off at any moment, but he is getting less and less full by the moment, so lower than the recommended bitrate. I don't know what to do about that, YouTube. So we're just gonna press on. Okay. This is a bit. Anyway, so we've created this function for registering routes to the server, and let's refresh our memories about how we are actually going to do this on the client server protocol, the network. So, geez, here. So, on the protocol, I am going to have a list of addresses, and those addresses can be to other nodes on the network. And you are just going to, at a random time interval, ask me for my list of connections, which will be a route on my network. So we can kind of guarantee that on our network, everyone is just going to provide this service. And yeah, so we know that every single node on the network is going to have a certain route. So if we go into our constructor for the server, well, I suppose we should do this in peer-to-peer. Our peer-to-peer constructor should do this because we don't know that this is true for every server. We know that they might want to register routes to every server, but we don't know that every server is going to want to provide a list of addresses. We only know that our peer-to-peer network is going to do that. So let's hop over to that, and let's finally get rid of that other window. Working on a laptop here. Some real estate is in demand. Anyway, so in our peer-to-peer network, where do we actually create server? Create our server here. So let's register a route to that server, one that we know will exist. So peer-to-peer.server dot register routes, and this takes the address of peer-to-peer.server. See, that's where it becomes easier, is that I don't need to pass it in the register routes dictionary and think of this as a dictionary. I can pass this in as a server and think about this in terms of a server. So now I just need to pass in the function and the path. So function, we're going to call they always are going to return a character array. Call it known hosts. And what does it have to take as argument? It itself is going to take a server pointer and a request string. So okay, that's going to be our known host function. This is going to be the one that looks at the list that we have and our linked list here, and actually checks or goes through and reads off everything that they have. So let's see, we've created our known hosts, and we are going to register that here. So known hosts, and then we need a URI to go with it. So we'll just put in /known hosts. Now, with the URIs or the URLs, that is something that I am copying from HTTP, of course. And the reason I am copying it is that it just really makes a lot of sense. Because a lot of times, let's say I make this into something where I am storing information in like hundreds of thousands of little files, and I want to provide a route that is just going to give you the file you ask for in that specific folder. Well, it's really easy with this URL method, and where you just basically use the path of that file. And I really like that. And it also, if you wanted to do something specific, like what I want with this known hosts, where it has nothing to do with files, it also just kind of makes sense from a logical perspective. So in the future, if I want to, we could change this to /services/known hosts. And while this might not represent any folder structure that we have internally on our machine, it does actually make sense that known hosts is a service this node provides. So I'm fond of this URI URL method as a means for differentiating the different services that a node offers. So I'm going to leave it here for now, but I'm open to suggestions for different ways that we could do this on the network. Okay. So we have registered this route to the server. And now we just need to define what this route is going to do. Excuse me, I may need to sneeze. Excuse me. Okay. So, add it to the Git repository. That way, if you're following along, all right. Great. So you should have access to that now on GitHub. Again, link is in the description for that. Anyway, so now at this point we have registered that route. Now we need to define what this function does in terms of character point. I'm a bit particular about how I write these. So let's define our hosts. We're going to use the server's linked list. You'll have to excuse me for one moment. About that. Beginning to feel a bit like spring around here. Pollen is affecting my allergies. So in order to avoid just sneezing directly into the microphone, I will walk off and then take care of that off to the side. So sorry about that. See if anybody panicked over here in the chat. Nope, you guys seem fine. In fact, you've attracted one more person. So unicorn. Anyway. Okay, our known host function is simply going to return a character array that is going to be a list of all of the IP addresses stored in that struct, or in the linked list, basically. Now, we know the format of an IP address. So we see, for example, right now, I'm on one who has an IP address. If I was to use it, 127.0.1, that is my loopback IP address. And there are 4 sections to our IP address. 1, 2, 3, 4. And those are separated by 3 periods. And each of these sections has a maximum value of 255. So if we assume the maximum value in each one, that gives us a set of characters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we can just assume that there are 15, well actually 16, because we need to include that null character. There's 16 characters in every single item in that list. If there aren't, we'll just have some extra space. So first we're going to create a character pointer called bonds. And we are going to set it equal to malloc. And we are going to allocate some memory on the heap. So we need to include the standard library. So we're going to malloc a certain amount of size. And that is going to be the server dot I'm sorry, we want the peer-to-peer. We want access to its linked list, known host. So instead of passing in, we may have uncovered a problem here. So, so, this is a problem that I've run into a few times. Familiar with this devil. So we have an issue of where things are defined, where they make sense, and where you end up using them. So, in our server, we define our register routes. So the highest level object that we can talk about in this context of the server is the server. That is the newest object. We've just created it in this file. And so here in our route function, we can only pass a reference to the server. But we need, over here in the peer-to-peer section, we need to pass it a reference to a peer-to-peer object. Because when we access the list of known hosts, that list of known hosts exists at this level rather than at the server level, this level. So, how are we going to get it there? Well, we could say that in our server, instead of taking a character pointer and assuming a request, we could take a void pointer, and then you could put structs in that just kind of wrap any arguments you want to send. So if I want to send my peer-to-peer network, I could just wrap it in a struct with the request string and everything else that I would need. Or I could use variadic functions where we could just pass in the number of arguments that I want, and I think a void pointer is more elegant, personally. Well, then I suppose, does the route need access to the server? Let's look at our actual I don't suppose it does. I don't suppose it does. So instead, this. What if we just have void pointer arg? And then anything we want to send into that function for any purpose, anywhere, we can just wrap in a custom struct, pass in, and then cast once we need it. So that seems to give us the perfect solution. So let's go ahead and change that everywhere. Void pointer arg. And here, organize these a bit better. Route function is going to take void pointer arg. Which means that over here in peer-to-peer, once we have created we're going to register routes, and we don't need to pass it this. Well, we don't need known hosts to take this. We need take a void pointer arg. Okay. Upset about some things. Delete this for now. Okay. Something, just keep it quiet for now. Used response, that's fine. Oh, not yet. Then server.c, server.h, though we have in fact changed that. So it should be good. So I'm going to go there and build it, and it succeeds. Okay, we're good to go. We're good to go. Okay, so where are we? Okay, we are at known hosts. Known host takes a void pointer as its argument. And we can say that we know that that void pointer is going to be what? So this function is called how are they going to get it? When are they going to get it? So the server is, let's look at the main file here for a second. So okay. So at HTTP. The launch sequence. What would happen was, see the chat. Nothing going on? Okay. Ooh. 8 people here? Jeez. Hello, everyone. Nice to see you. That's pretty sweet. Nice. Welcome. Anyway, in this launch sequence, you see we enter this infinite loop, right? And it is going to accept whoever connects, and then it's going to create a thread job because this uses a thread pool of the handler and the client server object. Okay. So, of course, there's a bunch of objects. Anyway, client server contains the address of the client as a socket and the server, okay? And let's see. The thread job takes the handler. Here's the handler. So the handler is going to, okay, goes into the routes that, so this is that same dictionary. Okay, it's going to search for something. And it's going to search for the URI. And then once it, so, okay, so in our, oh boy, so this requires some explanation. I apologize. Let's look up an HTTP request. So, nope, not what I'm looking for. Tutorials point. Thank you. Okay. In HTTP, we have a request line, 0 or more header followed by CR, carriage return line feed, an empty line, optionally a message body. Who designed this? I don't know. I don't know. It's not, seems a bit interesting to me, but anyway, the point is that the first thing you're going to get is the request URI. And so the user is going to send you something that begins with that URI. Let's see if we can find an example somewhere. Here we go. So here is the method, and it can be one of 9 methods. And then they give you the URI, so there's another variable here on the first line. Then they send you the HTTP version you're using, so that's a third variable on the same line. Then they have this set where each line is an independent key value pair, except some of them have multiple parameters on the same line in the value. And then optionally, there's a blank space and a message box. So anyway, the whole reason that I brought you here is this, that they have actually sent they haven't sent us, all they've sent us is a string. It's just a string that looks like this. And so part of that string we knew was going to include this path. So we are really free to do absolutely anything here. So what I'm thinking is that we're going to design our own version of this, something that's a little bit cleaner, something where it's more consistent with what it's going to do rather than mixing key value pairs and space delimited values. We'll make up our own, and basically The only part of this that I like is this, where we have a path, and I like the paths. We will keep the paths for now, at least. But I'm open to changing that. If anyone has any ideas of something totally different we could do, I am open to that as well. Anyway, let's come back over here and right. So this in the HTTP server, we do this with threads, and anytime a client connects to our server, we are going to accept that connection and then create a thread job, and that thread job is going to be this handler with a reference to the client and a reference to the server and the address of the client that is passed into this handler. So the handler takes that as a void pointer, and it is going to search. Well, first it is going to read from the client. So it's using that client's address to read in what is being sent. And it's going to use that to search the dictionary of routes. And, oh, it does that right here, actually. It searches the dictionary of routes for a given URI. And then it will actually execute that route function, saving the character pointer response into a local variable, which it will then write back to the client, close, will then free the client server object, call the destructor, and die, basically. So, what do we need to implement over here? So, we are essentially skipping a step in our way of thinking about this, because we're trying to register a route to something that has no implementation for actually accessing. So we don't really know what it's passing in, what it's getting back. I suppose it is still safe to assume that if we're going to be using the same function calls, what we're going to be writing back to the client will be a string. So I think it's safe to say that we are going to pass in a character pointer, and a void pointer argument is always pretty safe. We just need to think about like what is possible to send in. Probably going to want our client code to be multi-threaded as well as it was at the HTTP server. And so we'll probably do it in a very similar way. So we want to make sure that we have access to any need. And I suppose that our known host one, assume that we will have exactly that's the thing, is will we need to wrap things in the future? Because if we do, I should wrap it now. But if we don't, in the handler function, call the route function, send it a reference to the server, and the request. I don't know that it actually needs the reference to the server. Why would it? If it just takes in a character string, turns a character string. The question is, once this gets called, I don't know what to pass into it. If I'm doing it in this handler, I have to pass in time. Do I? Unless I do this in a totally different way, where URIs are not actually linked. Okay, so I suppose if we assume that when the client sends us something, they have sent us something that we can pull a path out of, and know what they're asking for because they've given us a path. Well, let's just work on pulling everything out of the list. So we can assume for now that void pointer points to the peer-to-peer object. So peer-to-peer pointer equals arg. Okay, so that'll implicitly cast that argument peer-to-peer network. We'll deal with how it actually passes things in later. We're doing this in a strange way because that interface was designed usage as a web framework, not as something that you actually build on in initialization. So I'm doing this in sort of a strange way, which is neat because it's sort of testing the edge cases of that system, but it's not how it was intended to be used initially. So let's keep going. And well, I suppose what's actually more interesting here is that, like I've been saying, I intend for us to actually use this at some point. And since I am basing the design off of my web framework, there's no reason why we couldn't all serve something else. So in the end of here, we might all be able to create our own custom web application that has a bunch of different routes and accesses a bunch of different information on the peer-to-peer network, and you would be able to define all of that information yourself just by creating these functions that accept and return anything, basically. So we don't need to assume that there's a string in there. We can wrap that string in something else if we need. Anyway, so let's see here. Okay, so we've cast this as a peer-to-peer object, and we can say that we need a character pointer called known. Oh, let's call it hosts. We're going to set it equal to malloc. And how much size do we need? So size of a character pointer. How many characters did we say were in that IP address so long ago? So if we have 255.55, that is 1 for the terminal character, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16. So 16 characters. So we're going to say a character array of 16 characters. So that's technically just 16 bytes times the number of elements in the list. So let's just simplify that. So here, known hosts dot length, so the number that there are, times (16), because we can just assume the max size of each. Do I have the string library in here? I do. So now what I'm going to want to do is iterate over my list of known hosts. So for int I equals 0, I is less than known hosts. Nope, not known hosts. Oh, I might peer to peer known hosts dot length. And I should probably change this function name because I'm getting a bit confused between the two known hosts. Anyway, while it's less than that length, and I plus plus. Here we are going to do string cat. So our destination is going to be hosts, and our I guess the one we are concatenating onto hosts is going to be peer-to-peer known hosts dot retrieve. Pass this a reference to known, not known hosts, but peer-to-peer known hosts dot, nope, sorry, just the list. We want to retrieve I believe. Is that all we need in that function? Retrieve function from the linked list. Working with it this week, I should know. Yeah, it just takes the list and the index. Turn. Okay. So this is going to concatenate hosts, which is, will start out completely empty, just as zeros. And then it will go through the list one at a time and just add on to the end of this hosts every single IP address, and we should actually separate them with a comma. So okay, we're also going to add a comma onto the end, and so we'll have a comma delimited list as our return for this one, but we need to add more space. So we are doing that times 16 plus length. Well, we'll just multiply by 17 then, because we can just assume that for every single item in the list, we're going to have a comma associated with it. And unless there's a way we can do that without including the end. I think we'll just have a comma on the end. We'll deal with commas on the end later. But anyway, yeah, if we just assume that every single object in there has a comma with it, then the size of our list just becomes one character longer, so 17, 16, so we can just put it there, and so we can just put that there. We have plenty of space. Okay, good. we're doing well here. Let's see. How's the chat? Quiet. It's quiet. That's okay. All right. Feel free to ask any questions, guys. I'm happy to answer anything about what I'm doing here. So I am indeed live, correct? Yeah, last week. I don't know if any of you actually saw me last week, but I streamed for 2 hours only to find out that I did not stream for 2 hours. That was bad. Anyway, so we have concatenated that string with every single person on the known list, one at a time, separated by commas. Now simply return hosts. That's it. Unused variable response. Well, there is no variable response there. It's called peer-to-peer. Anyway, so that is our known host function. So defined it and we have attached it. Uh-oh. We're going to have to lose the face cam in just a moment. Okay. Doodles for now. Keep going, but okay. So we have registered known hosts, and what I am basically imagining here is the client is going to ask for something. The server is going to send something. The client is going to just send known host. So remember, the client's on a timer. And every so often, that timer is just going to tell the client to basically pick someone on his network at random and ask them for their list of known hosts. When I get that, the server is going to activate this function and basically create a list of its known hosts separated by commas. 127.0.1, comma. 7.0.0.2, 127.0.0.3, comma. That's exactly what its response would look like. And the client will then be responsible for parsing this. So they will use string tokens, and they will separate it on the comma, and they will just read this, and they will check their list of known hosts and say, do I have this? And if they do, great. Move on. So they'll start here, and they'll check for this one. And if they do, then they'll keep moving through the list until they find one where they don't have it in their list, and then they'll just add it to their list. So we'll basically grow the list of known hosts exponentially simply by asking other nodes on the network who they know. Gain a lot of friends by becoming friends with your friends' friends. Our function here is ready to do that. So, problem is our peer-to-peer doesn't seem to have that in its launch sequence yet. Okay. So here, we get the request out here. Ooh, something is happening here that's worth mentioning. Memset. So and another question. Thread safe. Because ultimately, if our server is multi-threaded, then we might have a problem with this. I'm going to go ahead and do it. I'm going to go ahead and memset hosts that size. We'll just go ahead and clear it out every time just to make sure that we are actually working with an empty string at that point. And what I'm thinking is, if let's imagine our server is multi-threaded. Well, first of all, there's a couple of things that I'm imagining. If we execute this 3 times in a row, one after the other, 1, 2, 3, then it's possible that when we use malloc, then when we are on the heap, we could allocate a certain block of memory, deallocate it, and then reallocate it if these things are run concurrently. And the problem with that is that, quote unquote, deallocating on the heap seems to be more that it just moves the pointer rather than actually turns them back to 0. And that's fine. It would take extra processor steps to turn them back to 0, so I understand why they don't. But if we reallocate the exact same block of memory in a different thread or in a different iteration of this, it's possible that we could end up reading some of what's there from a previous one, and we can get weird results. So we do memset as soon as we allocate that space. We are just going to manually set everything in there to 0 just to make sure that there's nothing residual in there. Then when we come in, we can concatenate all we want to it and return it. Now, I think this should be thread safe, because we will locally here allocate some memory on the heap, and if another thread tries to do this, it will just itself will just allocate memory elsewhere and then set all of that memory to 0 and do this. So it should be thread safe, but it was important that we used our memset there. So let's save that, and let's come back over to our main. So once we get our request, instead of just immediately printing, instead of that, let's read the request. So if string compare request and known hosts, that equals 0. We want you to do something else instead. We want you to call p2p dot, well, I guess do arrow where are our routes? Our server dot routes dot search and we want to search it for, first we need to pass it p server.routes.routes because we need to pass it the dictionary itself, though I'm feeling like I had an easier way to do this previously. So routes server.routes.search. Yeah, that's basically how I did it before. Okay. Fair enough. Pass it in the routes. And here, what are we using as keys in this again? Let's check. So where do we register routes? Here. So a path. So we're going to throw in request, and what else do we need for searching? Size of it. Okay. Okay. So if the client asks for this route specifically, suppose there's a better way to do. This is a bit of a. Let's leave it for now. It does in fact work. So we read in what the client says, and then we do string compare with what they've requested, and this single known host string, if it equals 0, that is that they are equal, then we are going to search the routes, and essentially we're going to get the function, execute the function. But there is a better way to do this. So we look here in the launch sequence. Somewhere. Then the handler, where do I execute? Ah, you see? Okay. See, over here, I was wrapping it in this route, and that gave me the ability to call the function in the handler. So how am I going to call the function here? It's going to return the data to me, but that's going to be a void pointer. So I need to cast it back. And suppose I could define a variable if I just want to do something quick and dirty for right now. Yeah, let's do quick and dirty for right now. Quick and dirty. So this is going to be a function that turns a character pointer. We're going to call it known host route. We're definitely not going to do it like this in the future. I just want to make sure that it works. And this takes a void pointer arg. And we're going to say that if indeed that's what the client is looking for, we're going to set that variable equal to what comes back. Okay. So you can see why this was a bit confusing. We skipped a step, if you recall. So in the HTTP server, I would wrap everything in a route object or a request object. And I would wrap all of these things into these predictable objects because I knew what the protocol was. And here, I don't actually know what the protocol is yet. We are kind of making the protocol as we go. So I end up having to come up with these interesting solutions where I am instantiating a function pointer in a single line as if it were a variable by calling a the search function on a dictionary embedded in a server, embedded in a peer-to-peer object, and sending it this request for known host. It's you can see why this is a bit complicated, but I think this is going to work. So we have initialized this function by calling this and casting that void pointer back. So now we're going to want to execute that function. So known hosts route, and we know that our argument, what are we assuming is coming from this argument? Peer-to-peer, host route, a reference to the peer-to-peer thing itself. So pass it the address of, don't need the address of P2P, need P2P. P2P is already a pointer. So yeah, we've just cast that from arg as well. So we could actually just pass it arg, and that'll just pass it right along. So let's just add else. And copy just is that going to mess anything up? Yeah, we need to grab the client address earlier. We need to grab that up here. Reason being that we need that to exist down here. That only exists if we run this else block, then we're going to run into a problem. So we are just going to go ahead and I'm just making sure that, yeah, we don't actually do anything prior to this, so moving it will be fine. Okay. Good. Yeah, I think we should be good. So if we get this known host request, then we are going to call this function, or we're going to retrieve that function. Then we are going to call that function. We're going to pass in our peer-to-peer struct as its argument, and it will then execute this, and we will actually want to write back to the client, and write so client. Okay, so we need this first. So first we're going to get the response. We're going to get a character pointer called response. We'll set it equal to the result of the function. So we're going to pass it response and size of character array, string length, because again, I was running into weird problems. That seems to fix them. So that's what we're going to do. So we'll write that back to the client and they will be able to see it. So now all we need is to check with the chat. 4 people here. Welcome. Message retracted. Loathing kernel, I would have loved to have heard from you, so it's a shame. Anyway, I'm starting to feel it in my throat a bit. We've been going for about an hour and a half now, so let's go a little further. Okay, so our client, or our server, is now going to hopefully successfully respond when the server asks for known hosts. Its building is successful there. Let's run test. Build succeeded. Oh, okay, this isn't playing around. Server running. Responding to message. Okay. Now, I need a way here to occasionally ask for the list of known hosts. Okay. So let's see what we do here. Let's go first into our peer-to-peer, into our known host, and let's just put in a statement. Known hosts requested. That way we know anytime the client is actually going to ask for it. And let's see. Where is our peer-to-peer user portal? So there should be an infinite loop somewhere here. Client function. And we define the client function over here. No? Here's our infinite loop. And we are just kind of consistently calling client.request right here. So what we can do is actually create for instance, a clock. And we can set a clock, and we can just say after a certain amount of time has passed, when you get to the top of this loop, just go ahead and ask the first person in the list for their list. So I am actually not super familiar with clocks in C. So let's take a look. Clock. Time.h, okay. Looks like we define a clock type. Here they defined 3, start, end, and total. And you just call the clock function to get now. So I'm going to say in the client function, oh, F, okay, I see it. Waiting here at fget. Okay. Sorry. Okay. So what am I trying to have it do here? Okay, let's get our clock. So start, well, clock, t, start equals clock. And really work, does it? So basically going to wait until the client or the user has gone a specific amount of time between two messages. And once they have gone for that amount of time between two messages, then they will send it. What we really want is a thread, separate thread that is going to handle this itself. And you know, I knew I should have done this when I was creating the peer-to-peer object. I was thinking of creating it itself as just kind of an implementation of a thread pool, actually, and having the client function and the server function running as independent threads. But what ended up needing to happen was that if we look here, what we do is we create a thread. What actually executes? We create a thread, and we send the server function to that thread. And then we actually execute the client function. So it actually only creates one additional thread. Whereas I was thinking about doing all of this for both the client and the server function. We lost access to be able to type things in. So what does this mean for what I'm talking about right now? So here, this is the client function. I need thread for a clock, and that clock is going to kind of run on its own, unless I want it to be tied to like how long the client actually waits in between sending two requests. So anytime they go more than 30 seconds between sending one and the next, then after they send their message, they're going to ask someone for their list of. Let's just do that one. That one's going to be a lot easier than actually creating a thread, and we can just see what happens as they enter this loop, get a start time. Then we get to fgets, and that's where we're just going to be waiting to get some input from the client. And once I type something in here, then we are going to go through my list of known hosts, and we are going to send them my. And here we are going to get an end time. End clock. So if I have been waiting here for more than a certain amount of time, then we are going to make that other request. So if end start, what does that store at? I'm in seconds. Returns the number of clock ticks lapsed since the program was launched. Divide by clocks per second. Okay. Do I just have that right there? I put these in parentheses. Divided by. There it is. Great. Okay. Apparently that's a constant defined somewhere. And so basically what's happening is this is returning the number of CPU cycles that have occurred since the program began. So if I hit play, then as soon as we get to this line, we are basically storing the number of CPU cycles that we have had to execute in order to get to this line. Then once we get here, we are also going to save the number of CPU cycles it took to get to that line. And my CPU runs these cycles at a certain rate per second. So we subtract the start time from the end time, then divide by that rate to give us the total number of seconds that it took to run. And if that number greater than, let's say 10 seconds. Let's make it longer. Greater than 20 seconds. We're going to ask someone on our list for their list. So we're going to client.request address of client P2P known hosts.retrieve address of P2P known hosts, and let's just take the first one for now. That's going to be a problem. That is going to be a problem because we're always taking from the first person in our list. What if that person goes offline and we lose them? Well, we're only going to continue asking them. At the moment, we have no way of actually cleaning up this list if we want to or need to. So yeah, it's going to be a problem that we're only ever taking the one in index 0, but so be it for now. Okay, so we're going to ask this person for what? We're going to ask yes, okay. And there's something else we should eventually add. So this this part right here is quite janky. I must admit, this is quite janky because it doesn't really build anything into itself very well. So here I am like having to deliberately write known host for this request. And if I want anything else, it's going to have to kind of deliberately do. The point is that I just want to show that the functionality is there, that we can now specify different things. So for example, what's happening right now is that if it gets absolutely anything, if I send absolutely anything to this server at all, then it is going to, where is it? Where's my server function? Here. Okay. Unless what I send is known hosts, then then it is always just going to print what I say to the screen. That's always what it's going to do, unless I say known hosts. And this is all manual. I could have something in here that would basically search the first line of my request for a matching URI in the dictionary. There is one, great, execute it. There's not one, we could even define a third or fifth section of functions that you can run. So maybe if there is no URI for it, you try and see if there's a file that matches that exact path. And if there is, read it and return that. And we could just specify a bunch of different things so that all we have to do is tell it what happens. So here we can replace this with a single function that just handles things. And I don't think I'm going to do that right now, but basically what I'm hoping is that now our known host lists are going to be shared with one another on a certain timer. So if I build and execute this whole thing, let's see what the chat has to say about it first. What do you guys? Nobody saying anything? That's okay. Quite a number of views here today. That's pretty great. Welcome. Glad everyone's been here. Anyway, so yeah, basically we would be able to take out all of these if-else statements and make it a little bit more elegant and less manual. But let's build it and run it, see what happens. I wait 10 seconds or 20 seconds. If I remember correctly, I've told it to ask for these known hosts after a certain period of time. And when it does ask for known hosts, it prints that. I feel like that should have started. When we make the known host, I suppose I could just make it manually. If I just type in /known host, see that it reads that as something else. So we seem to have two problems going on here. One is that if I just type in /known hosts, which is what it's supposed to be looking for in my request, /known hosts, then it thinks that's a message, prints it out. And it also does not seem to actually be, where is it? It doesn't seem to be actually sending it to me. Where did I do? Now I have to find this somewhere where this known host thing would print. Yeah, known host requested. It's never printing that. So we need to find out why it's not actually executing this. Tie to the path known host. So let's stop it. Let's put a few breakpoints. Okay, so let's put a few breakpoints in here. So let's check that. Whatever goes there, I want to. And what else? Show me these. I want to see what this is. Okay. Okay, so we've written hello. A request just says hello \n. So that seems to be our first problem. Okay. And start divided by clocks per second. And what is this? Not telling me. Hello. My client function should have created a new client, created this, set mem. That's waiting here. So this should be on a 20 seconds timer. If I wait 20 seconds, type in yo. Okay. Request. And start. Not a whole lot I can tell from looking at it. Apparently that wasn't 20. I'm going to set something on my watch. And let's wait for 30 seconds and see how it responds to that. You guys are quite quiet in the chat. I'd love to hear from you. What brings you here? Have you an interest in building a peer-to-peer network? Okay, that was 30 seconds. So we should, in theory, stopping it at 40 seconds. And do those seem to be exactly the same number each time? No. It can't be. A very big difference. I wonder if it like resets once it gets to a certain number. Yeah, see, it's not doing that like that. Do n minus start greater than. Say greater than 50. I forgot what those numbers were, so stop it. Yeah, it's gonna fail to bind to the socket, so let's come back to the chat, see if you guys said anything. No, nothing, but that's okay. Yeah, ultimately, I would like for this to become the chat for itself. So, like, while I am programming it, if we've had good views on this particular video, actually. You can see the stats right here, but we would need more views for this to work. But essentially, the idea would be that I can use this chat network as a way for you to help me build the very chat network that we are working on. So that would be kind of neat. Anyway,
It often fails to bind to the socket if you try multiple times in a row, so I'm going to run it again now. Now the server is running. Say hello. Okay. End minus start. That's definitely greater than 50. That's going to send that. But nothing. Okay. So we've entered an infinite loop somewhere. Have we? No, I suppose we haven't because it well, it sent this request. I'm going to send the request. Wonder if it's because I'm trying to open another client. Oh, this client is open because I don't actually close the client. Where do I close the client? I'm going to stop it for a moment. So the client is defined here, the accept. Who's this? Okay, this is a client on our end. I just do this every once in a while, whenever they make. So we make this request. Send it to the first person in our list. Send them to known host. Okay. Let's try something. Try search for that. Because I know I can type that in and get that. So let's see how this is running. Okay, so request equals known host backslash. This equals known host backslash. So should give us this. Played out known this. Oh, I was supposed to type slash known. Of course, I'm a fool. Yes, of course. Uh-oh. Didn't like that. Okay. Plot thickens. Okay. Got some more people here. Welcome. Okay. What does it not like here? It does not like my known host's vector response. Where is that? Where did I define my known host route? Try and no, not in main. Over here in peer-to-peer. Okay, so let's stop it. That's interesting to know because that's consistent, in fact. because since it just gives us that problem, it may in fact be sending that without getting it. So maybe it's getting stuck somewhere. Let's find out. Already news. Okay. I hope you don't mind giving me 5 minutes here. I am going to just grab some water, clear my throat, and I will jump back in and we will take a look. What we're going to do is see if we can stop it here and see if we're getting the request at all. And will we be able to bring the face cam back? Yeah, probably. Why not? 50%. Hey. Welcome back, ladies and germs. Okay, so we're going to run this. And we are going to connect to the socket. We are not going to fail to find it. We're going to succeed. The server is going to run. We are going to say, hello. Going to stop there. Our request is hello. Good. So it just prints it back. Perfect. And we are going to make the request. But nothing. We don't even get into our function. Nothing runs. So let's send /known host. Oh, because this one, okay, this sends known host. This should have sent \n at the end. Since we're doing it here, should get here. Good. We're going to, nope, bad access. Can't do that at all. Is this the problem? Null. Ah, okay. Okay, we really do need to change it. So we look over here. When I am actually registering the route, I register it as this, and that doesn't exist. So that needs to, and we'll change it everywhere. So we are actually going to, in the main function, add it down here. Well, we're going to ask for this. Hopefully it should run in the background now. And we gotta wait. See, anything in the chat? Nothing? That's okay. You guys are feeling shy. I understand. At the end of this, maybe we'll do a Q&A session. I'll tell you about some of the things that I have coming up on the channel, and maybe you'll be interested in doing that. Let's also check on Discord while we're here. Usually I do this on a separate screen, but things are still not working. Brooks is on. We could join him on the voice chat, but I'm not going to do that to him. That would be fun. There should be a link in the description to our Discord if you want to join us there. Anyway, let's take a look back over here, see if we can, in fact, run this. Server is running. I'm going to say, hello. This is giving us our hello request. Good. Check that. We are going to send that, and nothing comes from it. Okay, so let's send /known hosts. Checking that. Still bad access. Okay, what is the bad access? Response. So it seems to dislike saving the result of known. Also, doesn't seem to actually execute known host route. Does not seem to want to execute. Null. Let's see. Oh no, it actually has an address system. What's its own? Does it have an argument? Yes. And it should be this one. Yes. Okay. I suppose it's down here that response is getting this bad access. But it should be tripping our breakpoint. So let's stop it. And what I want to do, let's first check our route here. See, we should be tripping a breakpoint if any of this is running at all. Not. So that's kind of a clue. None of that is tripping. So if I actually delete this, it doesn't even bother saving it. Let's just execute that function. Okay, so that's nothing there. Expecting that. Oh, should have done known host there. Okay, so now known hosts. Oh, we still get bad access to client this time. Client is 7. Response. Hello. Yeah, we get it. We don't have access to client in there? That can't be right. Why would we have bad access? No help from you guys over here. That's all right. Let's see. Why bad access? This has an address. We know what this is. It's actually kind of an interesting address too. All the zeros in front of it. Like it's early on in memory, and since this is something that is created as a function, that makes sense anyway. But I digress. I wonder if I say I change it later. This is not going to fix it, but what I'm trying to do is rule out the known hosts route function as the culprit of this problem, because, oh, here we go. Grannon writes, what is character string? Yeah, okay. Yeah, you've seen it, Grannon. Okay. So this is just some thing that I found while I was doing the HTTP server, was that if I said the size of response, or I said the size, or I just said like the number of characters in response or something like that, it would often end up reading over and giving a bunch of nonsense characters because there was just random things stored in that section of memory. And so I found that the way to get it working consistently was to use size of a character array who has the number of elements that is the same as the string length of response. So I know that that is super weird, but that's what I have, and it's what has been working. I'm happy to try it the other way, where you just say like the string length of response. Let's try that. Let's give that a try in a second if this doesn't work. So if what doesn't work exactly. Okay. So here I'm basically trying to rule out this function as a problem. And so I was able to get to this line previously, and I was able to see that response was equal to hello. So let's see if I can change it afterwards. Server is running. Type in slash own hosts. I'm going to get here. Nope, it doesn't like that. Response currently equals hello. Seems that this memory address is the problem. And I wonder if I can. See, I was able to execute the function in. Let's take a look at my HTTP server really quick. So let's stop it. That way we can start it over. So if we look at the HTTP server, what is the relevant point here? So I was able to store things in the routes. Here's our routes. Oh, okay, I see. So we would store things in a struct called a route. And this route had the URI and the function pointer wrapped within it. Whereas over here, I have the dictionary storing a raw function pointer. Getting a bunch of notifications. Anyway, here we're just storing a raw function pointer as a void pointer inside of our known hosts dictionary or linked list. And I'm sorry, our routes dictionary. Yes. So when we search the routes dictionary for a particular URI, this known hosts, and it returns something, it is returning a void pointer. We happen to know that that void pointer is a function pointer, this function pointer. Let's double check that to make sure that that is actually correct. Character pointing return, known hosts, void pointer arg. Character pointer. Yep, yeah, that's correct. So we know that that is what it's actually pointing to, but it seems to not actually like calling it. I don't save the result though. Maybe it's this arg. No, because I should be hitting a breakpoint somewhere. Got server running. Known hosts. There it is. Can't even write hello though. It looks like it executed the known hosts route, but it never, first of all, it never tripped my function, unless this is it. No, because it should have printed. Seems like client is the problem. Well, what do I do down here? I'm taking a look at HTTP server, and I want to see the handler. So here, we get the route as a struct. See, here you can see Grannon, where I have the size of character string length URI. I have the same thing there. It's a bit strange, but what can you do? Anyway, so here we have wrapped all of that in a struct, and we can just call the function by saying route function, then pass it in. But it seems that doing it kind of raw like this, I feel like that's what's causing the problem. So how far back do we need to go in order to change that? We can define, let's define a route up here. So route, give it a unique name. What are we going to call it? Struct server route. Okay. And this is just going to contain character pointer returning called route function. And going to take void pointer argument. Okay. So then we can, instead of inserting the route function itself, we can create a new server route, call it route function equals, where is it? I already have route function defined somewhere. Registering the routes. It's what they pass in as a parameter. I'm sorry. They're going to pass in route function. And then here, what we're going to insert, do that for path. Here we're going to insert route. Size of route there. So now we've inserted routes. Need a semicolon here. Pass in the rest of route. Oh, no, sorry. Okay, yeah. I know how this works. I built it. I know how it works. Trust me. Okay, so now we are inserting this struct into our object instead. And so what we can do is actually pull it back out. But we're going to need to make this public. So let's cut it from there. Let's paste it into here. Because we're going to need to be able to get it back. So over here in main, doing this. So let's say struct route equals peer-to-peer server routes search. Passing it the routes. Request direct. And why do I not have a route here? C file. And I need to include, it should already be here. Server.h, that should be included in this. Let's see. H. Peer-to-peer.h. Server.h, it's right there. I think it's messing with me. I think it's messing with me. That was correct. That was right. Okay, so that gives us our route. And now we should be able to say route function. Passing in what as its, what were we passing in here? Do we need anything? Oh, address of peer-to-peer, which is already just arg. Okay. And we need a response. So character pointer response. Why is that wrong? That shouldn't. So I need to include the server right here. Oh, server route. My mistake, of course. Foolish. Okay. Server route. Expression of incompatible type. Avoid pointer. So this needs to be a pointer. So this needs to be arrow. And that should do it. Okay, so now we've wrapped it into a struct. We've wrapped our function in a struct. And that is first of all going to give us a little bit more control over how we allow people to interact with the framework and add things into the library. It's also maybe, if we're lucky, going to make this thing safe to execute so we have the correct access. Hello? Nothing on that one. Okay. Oh, here we are. Okay. They wrote back known host requested. But it doesn't seem that I actually got the list. They write it to me. And client. Oh, okay. I need to read the response from this. So what? Does that just return a character pointer, that request function? I don't think I was clear enough with that. Yeah, see, look, it just returns a character pointer. I just add one line, say printf that. And by printing that, when I run this, yes. So now it should print it whenever it receives that. So I'm going to take out my breakpoint. In fact, let's delete them all. Let's run it. Server running. Okay. Own host. Requested. Them. Interesting. No, I don't think so. You guys see anything there? No? That's all right. Oh, we got a lot of people here. Neat. Anyway, so what's going on here? What's holding up the works? What are you getting here? Very least. And stop there. Run that. Let's just. Hello. Make that request. That just moves on with life. How are you? That same thing. Okay. So printed that the known hosts were requested. It has called the function. Now it is writing the response, which is this, to the client. So it seems like my code for the client is just wrong. Yeah, okay. Okay, let's try this. Once that once. Okay. Stopped it. Now I have to wait. So what I'm thinking is something around here is fishy. And if we can just catch it there, see something interesting. Okay? Wait for the throat. Writes that. Gonna get the response. Never printed the response. And we get to see it. Too young. There's our response. Correct. Exactly what we want. Oh. Crashes before it gets to the next line. Not seeing any help from you guys. There's 5 of you here. Always use some input. Anyway. Let's see. So it's crashing before it hits the print statement. So that leads me to believe that it is in client.request that the problem is occurring. And we're just sending it to the first item on the list. That's down here. Oh, I suppose I don't want it there, actually. Oops. Don't have anything in? Nope. Let's look at the HTTP client or the HTTP server. What did it do with the client when it was done? Write and then close. Enough. Okay. And it seems that I actually forgot to close it. So where do I actually write to it? My server function. Write. Close. That does it. Oh. Looks like F gets picked something up. Accident. See, I think it put a double enter in there when it's supposed to. There's something else in. Nope. We lost it. I didn't really even see what happened there. Gotta wait. So, oh man, we've been going for 2.5 hours now. What time is it? 7:47. So we'll probably wrap up here for a while. We're getting pretty close. It's a shame that I'm not actually getting them to share their list yet, but we can see that it's really close because when we pause here at the right moment, we can see that it has the message ready. It's just not making its way over for some reason. Well, it kind of got stuck here in an odd way. I don't know what that was. make this request. And I wonder if I should be saving its response somewhere. Let's take a quick look over on, I keep going back to this screw everything. Yeah, screw everything. This guy, he wrote an article. Where is it? What is this? I don't know. We have things to do. Okay. Oh my. Anyway, what was this article? HTTP server from scratch sockets. There it is. So I'm looking in the client code for what we do with the response. Okay, is this the client code? Server side. And client side. There you have it. Hey, client side code. Okay. Client. We send something. What do I do in my client? Client.request. Okay, that's something that's a bit different. So client.request. We send them something. And then we read their response. Over here, we connect them. We send them something. We read their response. We read it into buffer. Here we read it into response. And then we return response, which has been allocated on the heap. That looks right. It all looks right. Unless so they have buffer here as an array, kind of literally as an array. And you might have a handle on address that might be causing the problem. What do you mean I have a handle on the address? So that comes from Sidoc? I don't know if I'm supposed to pronounce that, but it says I might have a handle on the address. I don't know what you mean a handle on the address. I assume what you mean is that response here, the address that is pointing to response, which is created here, that's this. We might have a handle on that, but I don't know what a handle is. And I'm not getting something in the chat for that. So keep moving. Let's stop it there. Okay, this is going to be on the client side. So we're going to be able to see if that actually makes it through. Let's run it. Say, go straight for the throat. Well, let's not. Let's say hello. Just the baseline. Yeah, we're going to get a response for this, but that response is nothing. Okay. Go. And then we get a second response. What is this? What is this? There's our request as known host, but response, get the single character. Whoa, 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 what is this? A capital I. Well, no, still nothing back from Sidoc, unfortunately. We got just a capital I, and these look like some escape characters. Waiting for more responses. Yeah. See that a response, blank response because it need to, and then another response that's just we're getting some weird responses. Stop it here. Play. Uh-oh. I think we lost it. Okay. Stop it. Give it a second and start it over. How are we doing over here? Still nothing from SideDoc. It's unfortunate. I would like a follow-up there. Anyone on Discord? No, Cats and Dogs is online, but I don't think he's joining us for the stream. And yeah, I don't want to harass anybody. Throw them live when they don't want to be. Let's jump back here. Already in use. How's my battery? 74. I think that qualifies for the face cam back. Okay, we should be turning in just a second. You probably have there we go. If I look on YouTube, my face should be returning in just a moment here. So let's try and run this again. Server is running. We're gonna send. Let's just go to known host. Okay. Request. That is going. That. Who is it going to? Well, we've already established that server IP. What is this? That's it. That's correct. Sending the message. Okay, so now we're writing a response. This is on the server side. It's writing this response, so it includes a comma. Okay, that's worth noting, is that us writing it back includes that comma. But that's not where we are ready to stop. Now we're going to return response. That is our response. Okay. Now we're going to send another one for known host. Okay. We're going to get another response. This one's blank. What is going on? We had it. We had it just a second ago. What happened to it? And I don't know. I'm starting to forget to look at the camera too because I was off it for so long. So yeah, I'm not quite sure. We seemed to have gotten it there for the briefest of moments, only to have it snatched away from us unjustly. So let's walk through that again and let's see. Anybody saying anything? No, that's all right. Okay, so walk through it one more time. What happens? Server starts running. Ask for say hello. Okay. Request here is hello. The response is nothing because it just the server side is going. This is the server, by the way. So, this is like I happen to be sending messages to myself. We can imagine these being two separate terms. So, that going. Now it's coming back here with another send. It's asking for the known host. This is off of our timer. So, I'm going to return this response, but the response is nothing. The response is just some weird code. This is a new line down here. What that was. Now, if we specifically ask for known host, now it is going to send us the request for known host. That is going to write to the client this response, which is in fact our list of hosts. Writes that back to us. Returns that response. Where does it return? Turns it here. Turns it here. I don't think that'll actually work because I just changed it. I might have to restart. Okay, let's restart. Gotta give it a back. Really would have loved a response from Psydoc. Anyway, got a good number of people here for this. A lot of you joined us. Glad you're here. Anyway, we can run this again, or are we gonna have to wait even longer? Server is running. Let's explicitly ask it for known / known. Okay. Send it. Write us back a response. That response here, and print that response. Huzzah, we've gotten it. Okay. Now what? Now it's going to send it another one. Shows feather right on it. Oh. Okay, so we actually get our response right here. But the problem is that it doesn't seem that our timer is working. So first of all, it happens every single time. So let's change this to 500, shall we? Make that last a little longer. And also add in we don't have any functionality in there yet to actually add it to our list. So probably do that soon. Let's, here's our timer. Here we go. And let's delete all those breakpoints. Let's just run it normally and see what happens. I'm going to give it some time to see if it does anything with the known hosts. So I don't know how long 500 is. So I want to see if I want to give it enough time to make sure this actually runs at least once. And we'll see what it gets as a response, if it gets anything at all. So far, it doesn't seem to have been getting anything, which is curious. Good for you. Yeah, it's not really saying anything. So let's send it known host. Gave me those known hosts. Thanks. And they say thanks back. That seems to work well. The only problem is this clock. This clock doesn't seem to work, so I have to explicitly ask for their known hosts. And once I get it, I am not necessarily doing anything with it. I'm just kind of printing it out to the screen. So it's not great. I think we have more to do, but we've been going for a few hours here, so I think it's going to be a good time to wrap it up for today. Summary, what we have done is essentially add a functionality to our server object that accepts routes. And these routes are basically functions that will be run when a user sends a specific kind of request. And since we're not following HTTP, we can make these requests follow any kind of formatting we want. Kind of leaning towards JSON on that, by the way. Anyway, so we have added this ability to add functions as routes to our server object. And this allows us to define by default in our peer-to-peer object, in the constructor, we can create a route for known hosts. And since we are doing this in the constructor, it's essentially saying that this node on the peer-to-peer network is guaranteed to provide this service. It's sort of like a minimum service to provide. It's just to let other people know who you know. So we can register that route to the peer-to-peer object right at the beginning using that register routes function. And in our case, this function basically just goes through a linked list, which we already have sorted, and it is going to turn that into a list of IP addresses separated by commas of everybody that this person knows, which they have collected themselves over here or in the main function, in the server function right here, where we are going to check in the linked list and insert and add anyone who connects to us to our list of known connections. So we've basically established here a way for them to share this list with one another. So they will take it, condense it all down into a string separated by commas, and then when a client asks for their list of known hosts, they can share it. And once we share it, we can take it, we can split it on those commas, and we can check our list and see if we are missing any addresses. And if we are, we can just add them in, very quickly growing the network into a more feasible and usable network of a lot of different nodes. It would be very easy to get things going. So let's add this all to the repository. So established first contact for nodes sharing addresses. Okay, so once again, the code is on GitHub. So you can check the description of this video and you would see a link to my GitHub account. And libeom is where all of this is happening. The test file is kind of the cutting edge. If you want to check out what I've been making here today, make sure you switch to the branch working. Also, you can join our Discord and anything like that. Feel free to subscribe to the channel, leave a like on the video if you enjoyed it. All of that helps. But mainly the code is available for you on GitHub. So I'm going to take a moment here. Let's take a look at the chat. If anybody has any questions about anything that we are doing, if there's anything you'd like to ask me about this, I am open to hearing your questions. So I'll keep an eye on chat for a while I talk about what we are going to be trying to do next. So, what we have next, we have some choices next. What I want to do is, well, obviously we have a lot of work to do to actually get the peer-to-peer network going. But once we actually get those foundational things done, I would like to do something that is a bit of a blockchain with this. By the way, I'm looking at this thing here on my screen, and if I make this full screen, maybe you can see. This is probably pretty weird on camera. Anyway, looked like my name was hovering above my face, but I don't see it anymore. Let me know in the comments if that's weird. Yeah, I can see it. I can see it there. But anyway. So what I'd like to do is something that's kind of a bit of a blockchain so that we could be on the network with each other. And if I am going to send out a message, what I would do is essentially hash that message. And that would be my entry fee. Now, I would actually be, since I mined the blockchain in doing that, I would get a reward for it. but it would be a very small one since my sending out a message is a very small action, requires a very small cache. And basically that would be the foundation for the network, is that everything is done kind of on a blockchain, and we can kind of just add the functionality for these little interactions that people can have. And in the end, my view for this is something where, say I am working on a particular aspect of the network. So let's say I was working with multi-threading. Then you could do something where you are using this chat network and its blockchain to kind of filter out the help that you would get from a live chat. So I happen to have the opposite problem that a lot of live streamers have, where my chat moves very slowly. But I've seen a lot of live streams where it's just impossible to even read what these people are saying. I don't see it. So I'm thinking it would be interesting if we could create this peer-to-peer network and implement it in such a way. Then we could actually write some algorithms using some machine learning or something like that that would allow us to kind of filter things out. That would be really interesting. As an example, if one person in the chat were to ask, how old are you? Another person asks, when's your birthday? Another person asks, how many years do you, or whatever they ask. Then I, on my end, rather than seeing those questions all whiz by, I could have an algorithm look at it and say, this many people are asking how old you are. So that's sort of what I'm thinking. But I can hear my voice a-fading, and I am not seeing many questions coming in the chat. So let's talk about some challenges for this week. So I would like to leave the door open for anybody who missed actually there's nothing to miss because it's still going on, but sorting my linked list. So where is it? Linkedlist.c. So my search algorithm is binary search. That's going to be pretty efficient. It's going to be hard to beat binaries. But the sorting algorithm is bubble sort. Not going to be hard to beat. So if you would like to try your hand at writing a sorting algorithm for my linked list, then there's a video on my channel where I talk about my implementation, and that will probably be useful for you, and also my implementation in the first place. So both of those will probably be helpful, and I would really like to see some submissions for sorting algorithms. Show me what you got. I'm very interested. Anyway, so what are we going to be doing next time? I think next time we're going to need to pick up parsing the string. I don't think I want to do parsing on camera because parsing strings on camera is a bore. So probably might do some of that off. Maybe I will implement them searching the linked list and sorting the linked list for duplicates and all of that. It's not the most exciting, so I might take that off. So get the synchronization of node address lists done off camera. And then that leads me back to a question. So I'm going to put a poll up on YouTube, and I'm going to ask, what should we do next? We can either go into some third-party libraries, and I could use I don't really like using third-party libraries, so I will use it with discretion. But we could use some third-party libraries to get things like SHA-256 and what's the other one I was thinking? JSON. Being able to just read and write JSONs would be really, really nice in C, and parsing strings is so we could download two libraries kind of like that, and we could possibly get that working. But let me know what you think. I'm going to create a poll on the channel to let me know what we think there. I am not seeing anything in the chat, but I'm seeing the views go up. So I suppose if YouTube is using this as the thumbnail, that's it's kind of interesting to look at, I guess. But anyway, let's let's get rid of all of them. Let's see if we can bring back the code, the less popular stuff. Anyway, so next time, it'll depend kind of on what you answer to that survey. So yeah, let me know. Do we just go ahead and use some third-party libraries, or do you want me to continue making it hard for myself and coding everything from scratch? I'm happy to do either, so let me know. Anyway, my voice is becoming quite shot, so I am going to leave you for now. Thank you very much for joining me. If you are liking this content, I hope you'll consider subscribing to the channel. I make a lot of this kind of stuff. And you can leave a like on the video to help other people find it and things like that. Discord channel and GitHub links are in the description. So thank you for joining me this week, and I will see you next Saturday at 9 a.m. Toodaloo.